along the way, please inform me so that I'll be able to um, know it. Okay. So again, good morning to everyone. So now we proceed to our next topic. Our next topic for today, which is megakaryocytopoiesis or megakaryopoiesis in some references. So megakaryopoiesis was actually first introduced to you last semester when we talk about hematopoiesis. So hematopoiesis is the production of your blood cells, be it your white blood cells, your red blood cells, and your thrombocytes or your platelets. In the production of your red blood cells, we call it erythropoiesis, your leukopoiesis for your WBC. Now in hematology too, we would focus more on your megakaryocytopoiesis or now your megakaryocytes. So megakaryocytopoiesis is the production and the development of your megakaryocytes, okay? Or and eventually the production of your thrombocytes or your platelets. And megakaryocytopoiesis happens specifically and primarily within your bone marrow. To be specific, okay, ladies and gentlemen in the chat box, on what type of of bone marrow, what type of bone marrow does your thrombocytopoiesis your megakaryopoiesis happen in your, okay, correct, in your red bone marrow. Okay, it happens in your red bone marrow. Can you give me an area of your body where a red bone marrow can be seen? Okay, where can you see your red bone marrow, active red bone marrow that is participating in hematopoiesis? Okay, parts of the body. What specific bones are we talking about? We have your ribs, we have your sternum, correct? Your sternum. What else? Ends of long bones, okay, correct. Your skull, correct. What else? I think we're just missing one. Ayan, we have your pelvis as well. Correct. Your pelvis and of course your vertebrae. Okay? So thank you so much for that. So that your megakaryocytopoiesis happen in those areas, okay? On your screen right now, an example is on your long bones, okay? An example is happening on your long bone. So your pluripotent or your hematopoietic stem cell would further differentiate into your specific your specific blood cells. So let's just have a quick review first before we move forward. So remember that your hematopoietic stem cell that has your cluster of differentiation 34 or your CD34 is capable of becoming either your common myeloid progenitor or your common lymphoid progenitor. Okay, your CLM, your CLP or your CMP. Okay, your common myeloid or your common lymphoid. We will concentrate on your common myeloid precursor because this is where your megakaryocytes, okay, your megakaryocyte progenitor would arise. So from your common myeloid progenitor, ladies and gentlemen, it can actually give rise to your granulocytes and your monocytes, your eosinophil and your basophil, or it can also be precursors to your megakaryoblast and your pronormo and your erythrocytes. It would now just depend on the cytokines that will be released and that will be influencing your common myeloid progenitor. Please take in mind that the maybe some of you will be wondering, sir, yung hematopoietic stem cell, kailan nagiging CMP, kailan nagiging CLP? That is a random phenomenon happening within your body. I hope you still remember that part of the hematopoietic cells, the stem cell theories that were discussed to you in hematology 1. But take for example, okay, take for example, question question, what hormone is specifically produce, okay? What hormone will actually initiate your
There, can you guys hear me
Hello,
na?
can you hear me?
Yes, sir.
Hello? Hello, can you hear? Okay, so my question was, what hormone, okay? What hormone influences your common myeloid progenitor into becoming a megakaryoblast? What hormone? What hormone is that? Naririnig ba ako or it's just no one is answering? Okay, so the answer is your thrombopoietin, correct? It's your thrombopoietin. Your thrombopoietin would influence your colony forming unit GEMM, okay, granulocyte, erythrocyte, megakaryocyte, monocyte, colony forming unit into becoming your megacardioblast. So it your with the help of your thrombopoietin, okay, with the help of your thrombopoietin, it will actually make okay, it will actually influence your CFU-GEMM to commit itself, okay? Iko-commit niya yung sarili niya into becoming your megacardioblast, okay? So with the action of your with the action of your thrombopoietin, okay, your CFU-GEMM will now commit itself into becoming your megacardioblast, okay? Your megacardioblast. But before we go further, okay, but we go further to the megakaryocytes already. So your megakaryocyte differentiation and progenitors, okay, will start with the three stages of mega. Would start with the three stages. Okay, it will first start with the three stages. And what are those three stages? Okay, so kanina nga, gaya nung sabi ko, your megakaryocyte erythrocyte progenitor is your common myeloid progenitor. That is your CMP. Your CMP will further differentiate becoming your colony forming unit GEMM, that stands for your granulocyte, erythrocyte, monocyte and megakaryocyte. Okay? The CFU GEMM, okay, will be acted upon. Okay, ladies and gentlemen, it will be acted upon by your thrombopoietin and your interleukin 3 and your megakaryocyte colony stimulating factor or your MEG CSF. So with the help of these three, your TPO, your MEG CEF, and your interleukin 3, what would happen next? It would now influence your CFU GEMM to commit itself into becoming a full blast megakaryocyte or a megacardioblast. In this case, you would see that we already have your BFU MEG. Okay, BFU um, stands for your burst forming unit. Okay, your burst forming unit megakaryocyte. So as you can see, your BFU MEG is capable of reproducing itself into multiple cells. Okay, it is still capable of mitosis. Okay? Eventually, your BFU MEG, okay, your BFU MEG will further mature into your colony forming unit MEG, that is that is also still capable of mitosis. Okay? Mind you, these three stages of megakaryocyte progenitors are cannot be differentiated from one and the other. Okay? We cannot differentiate it microscopically. Let me just clear that. We cannot differentiate BFU meg from CFU meg microscopically because when looking in the microscope, magkakamukha lang. Okay? They look very the same. Okay? So what would happen next? This BFU meg and CFU meg are very much capable of mitosis. And when I say capable of mitosis, they actually undergo the regular mitosis. So meaning to say, the PMAT, prophase, metaphase, anaphase, telophase, all of those four are still happening. And of course, there is cell division happening or your cytokinesis. Okay? But eventually, your CFU meg will mature further, becoming your LD-CFU meg. If you're looking at your RODAC right now, LD-CFU meg is also known as your light density colony forming unit megakaryocyte. But if you're gonna look at the label below, it is already light density. Sir, may pinagkaiba yon sa text light density, dun sa picture low density nakalagay. Light and low, they are pertaining to the density of the cell, so they are both the same. So either of the two will be accepted. Okay? So your light density CFU meg, okay, is not capable of the usual mitosis. Instead, it actually undergoes mitosis. Okay? So when we say mitosis, mitosis actually mitosis endomitosis rather. Endomitosis um, endomitosis is a phenomenon or a form of mitosis that lacks your telophase in your cytokinesis. Okay, can I see a raise of hand if I'm clear so far? So your endomitosis, okay, your endomitosis, okay, your endomitosis is a form of mitosis. Is a form of mitosis that lacks your telophase in your cytokinesis. So what do you mean, sir? Instead the mitosis will continue, the replication of your DNA will continue, the growth of the cytoplasm would continue, but it will never divide. It will not divide. Okay? It will not divide. So, among these three, ano no,
Hello there. Can you hear me?
Yes, sir.
Rinig. Ayan. So, among those three stages of your megakaryocyte progenitors, I want you to remember the two. The first two, your CFU and your BFU and your CFU meg are capable of mitosis. But the third stage, your LDCFU meg, is the only stage of your megakaryocyte progenitors that is capable of endomitosis. Let me repeat that once again. It is the only part, okay, it is the only stage in your megakaryocyte progenitor capable of endomitosis. Again, is a endomitosis is a form of mitosis that lacks your telophase and your cytokinesis. Okay? It lacks your telophase and your cytokinesis. So, key gene that are actually responsible for endomitosis are actually your GATA1 and your FOG1, okay, your GATA1 and your FOG1. They actually influence, okay, they actually influence this gene, and upon the slowing down of this gene, your RUNX1, your cell, okay, your LDCFU meg will now transition into endomitosis. Okay? It will transition to your endomitosis. Okay? So can I see a raise of hand if I'm clear? Okay. Thank you. So moving on, let's go now to your to the other stages of your megakaryopoiesis. So again ha, itong tatlong to in cannot be differentiated, okay? So cannot be differentiated under the microscope. But when we proceed now to the morphologically identifiable stage, we have now your MK1, your MK2, and your MK3. So what would happen here? In your MK1 is also known as your megakaryoblast, your MK2 also known as your promegakaryocyte, and your MK3 is your megakaryocyte. Okay, your megakaryocyte. So when we say terminal differentiation, this is now the stage of your medical technologists based on their appearance, okay? Based on their appearance. So morphologically, we can now differentiate your MK1, your MK2, and your MK3. Okay? So with all the stages, okay, with all the stages, your and in this particular stage, your platelet shedding will now start to happen. Actually, we'll be talking about the megakaryocyte a few slides from now. So, summarizing what we talk about. So, we have different stages. We have your BFU. This is guys, okay, how when asked there, am I back na ba? Is it choppy na as in super walang maintindihang choppy or just, a usual erratic na audio? Is it really as in nothing is
Ano sir,
comprehensible already?
nawawala po ng parang 5 seconds tapos babalik yung audio sir.
There. Am I back? Can you hear me
Yes sir.
completely? Hello? Okay, so saan po ako nawala kanina? Hello? Okay, so moving forward, okay. So with regards now to your with regards to the succeeding stages of your megakaryopoiesis. So kanina, 'di ba, I was mentioning that the first three stages, the BFU, the BFU Meg, CFU Meg, LDCFU Meg, those are unidentifiable. So when I say unidentifiable, when you look at it under the microscope, you cannot differentiate which is which. Okay, under the microscope, let me just be clear with that. But when we reach now the succeeding stages of your megakaryopoiesis, the morphologically identifiable, we are now able to differentiate which is MK1, MK2, MK3, also known as your megakaryoblast, pro-megakaryocyte, and your megakaryocyte respectively. So guys, you need to be well acquainted with the other name of your MK1, MK2, and your MK3. Okay? Your MK3. Moving on. Okay? Moving on, we have this different stages. So let me just sum it up for you before we move on. So we have your BFU meg, which is the least mature. In your CFU meg, what is the things to be remembered with your CFU meg? It is a diploid and it can participate in normal mitosis. Your LDCFU meg, okay, is now the one that undergo your endomitosis. Again, what is endomitosis? A form of mitosis that lacks your cytokinesis and your telophase. But still, the growth of your cytoplasm still continue, the replication of your DNA, the replication and the growth of your nucleus still would um, the replication of your DNA and the growth of your nucleus would still push through. Okay? So, note, okay, please take note that all of these three, okay, all of those three that we talked about kanina, your BFU meg, CFU meg, LDCFU meg, they all resemble a lymphocyte under a bone marrow smear. Okay? A bone marrow smear. So if you prepare the smear, okay, and you look at it under the microscope, you cannot identify BFU meg. You cannot identify CFU meg and even LD CFU meg. But the question now is, how are we going to identify one from the other? How can we identify which one is the least mature and which one is the one that is actually undergoing endomitosis? The answer is through immunologic test or your flow cytometer. Okay? Am I clear so far? Is my audio clear? Okay. So what happened during immunologic test, okay, or your flow cytometer? Okay? During this flow cytometer, as you can see on your left, okay, on table 10.2 of RODAC, you can see that on the leftmost part, these are the megakaryocyte or platelet membrane marker. So these are like your antigen, okay? These are antigen that are located on the surface of your cells. Okay? So when we say located in the surface of your cell, these are like the identification tags of your cells. So what do we mean by that? Your MPL, ladies and gentlemen, your MPL is present in all forms. So meaning to say, I cannot use this, di ba? I cannot use this. Why? Because kumbaga, I cannot use this as the sole identifier of my of the stage, because MPL can be seen all throughout from BFU meg up until a mature platelet or thrombocyte. Okay? What else? Your CD34 or your cluster differentiation 34 is a stem cell marker. Okay? That can only be seen in your BFU meg until your LDCFU meg. Okay? Hanggang dun mo lang siya pwede makita. As it mature from MK2 into a mature platelet, it can no longer be seen. Okay? So, CD34 ha, pakikitandaan. What about your CD41? Your CD41, you can identify CD41. Why? How can you identify CD41? Because it can only be seen in your CFU meg and in your LDCFU meg all throughout your platelet. Now, the question lies, sir, can you help us understand this better? Can you help us identify na kapag if the problem set that was given to us, it was mentioned na the marker given or the cell is positive to MPL and positive to CD34. What would be the answer? Okay? Take for example, we have a cell. The cell is only positive to MPL and CD34. Kapag sinabi niyong dalawa lang, MPL and CD34, I can say that what we have at that very moment is a BFU or a burst firming unit megakaryocyte. Nagets ako kung ba't ko sinabing ganon? Kasi itong dalawa lang yung nakita ko, MPL at CD34. What about on the other scenario, sir? Parang mali yung gusto mong gawin. Kasi paano po si CFU Meg at si LDCFU Meg, how can I differentiate the two? They both have MPL, they both have CD34, but they also have CD41. How can I differentiate CFU Meg and LDCFU Meg? Anyone from the class? How can I differentiate CFU Meg from LDCFU Meg? So let's see. Um, the answer is within the lecture I had kanina when we were discussing. How can I identify, okay, how can I identify now if it is a CFU Meg or an LDCFU Meg? Kasi madali lang pag BFU Meg, dalawa lang ang positive. But this time, tatlo, parehas. How can I differentiate one from the other? How can I differentiate CFU Meg from LDCFU Meg? Endomitosis of LDCFU Meg. Miss Holyon, can you please unmute your mic and elaborate your answer?
Sir,
Hmm.
sir, kasi po yung CFU Meg, sir, nag-undergo pa po ng mitosis. While yung LDCFU Meg, sir, ano na po, endomitosis, sir. Wala
So
po siyang telophase and cytokinesis.
Okay, so in that sense, how will you be able to identify which one is undergoing endomitosis and the usual mitosis? Paano mo masasabing, ito yung nag-endomitosis, ito hindi?
Sir, wait, sir. Pag wala na pong telophase and cytokinesis.
Okay, what else?
Sir, I have no idea.
With regards to size, which do you think is larger?
Size. Sir, wait, sir. Sir, larger po yung LDCFU.
Okay, thank you, Gabby. So yun yung what I'm trying to point out, no, that when your CFU Meg and LDCFU Meg are already side by side, when we are only basing on the immunologic test on the flow cytometer, it is impossible to identify if we're just basing on the immunologic test. Okay, if we're basing on the immunologic test. But if we're gonna look into, okay, the diploid, okay, if it is still a diploid, okay, yung size ng nucleus, yung size ng cell, we can identify, we can discriminate one from the other. Okay, nagigets po tayo ha? So please remember that. So if in case you saw a problem, and then sinabi na all of those particular markers are present, but then 2N lang siya, pag sinabi nating 2N, that is a diploid, okay? That is a diploid, then we can say that this particular cell is only a CFU Meg, okay? A CFU Meg. But if in case it is 8, okay, I'm typing it in sa sa chat box. If it is 8, 16, 32, and in some cases, there are some LDCFU that are capable into becoming 128N. Those are all LDCFU. Okay? Those are all LDCFU. Okay? Those are all LDCFU. Am I clear? Clear ba tayo? Okay. Okay, moving on. Okay, moving on. With regards to your MK1, MK2, MK3, and your platelet, some of you would be wondering, sir, paano po ito? Pare-pareha sila ng immunologic results. Paano po ito? I can only differentiate MK3 and platelet with your fibrinogen. Ano naman ang sagot dito? How can you differentiate your MK1 to MK3? Anyone? Sige. 3 seconds and I will call somebody. How will you differentiate MK1, MK2, and MK3? If you understand what I was saying kanina. How? Okay, let's go to... Did somebody... Akala ko may nag-left pala ng meeting. Let's go with the arrows. The arrows, how will you differentiate MK1, MK2, and MK3? If in the immunologic test, they are all very much similar.
So, morphology po.
Okay, correct. When you say morphology, that you will be using your microscope. So these are morphological differences already. Okay? So please remember that. So when I talking about morphological differences, eto sila. Okay? Please take note of this one. So as you can see, by size pa lang, we can say that the largest of them all will be your MK3 or your megakaryocyte. Okay? Your megakaryocyte. You can also make use of what? You can make use of the nucleus. Okay? Please look at the nucleus. Okay? If it is round, it is MK1. If it is somehow indented already, it is MK2. If it is a multi-lobe, it is MK3. Okay? It is MK3. What else? What else can we make use? Okay? That's nucleus to cytoplasm. Okay? In MK1, mas malaki si nucleus kaysa cytoplasm. In MK2, okay, mas malaki na ngayon yung cytoplasm kaysa sa iyong nucleus. But in MK3, it is much bigger. Okay? The difference is much distinct. Okay? The difference is much distinct. Your cytoplasm is 4 times bigger than your nucleus. Okay? What else? The cytoplasmic color. Your MK1 are basophilic without granules. Your MK2 are basophilic with granular appearance already. And your MK3 are azurophilic with granular appearance of the cytoplasm already. Okay? So, please take note of those things that I mentioned, your nucleus to cytoplasm ratio, and also your cytoplasm appearance. Okay? And please remember this. With regards to definition naman, endomitosis is still present in your MK1. So when asked, what stage does endomitosis starts? What would be the answer in the chat box? What stage of megakaryopoiesis does your endomitosis starts? What stage did it all started, your endomitosis? Anyone? Can you guys hear me? Can somebody just confirm if you can hear me?
Yes po, sir.
Okay, the answer is LDCFU meg. Correct. Okay? Endomitosis starts in your LDCFU meg. If asked, where does your endomitosis ends? The answer would be your megakaryocyte, okay? Or your MK2. In your MK3, there will no longer be endomitosis. Endomitosis is absent. Why? Because this is now the stage where your platelet would start to shed off from the megakaryocyte. Okay? So hopefully we're clear with that, no? Hopefully we're clear with that. So I will be ending here. So next meeting, we will go to the different factors that influence your platelet production, and eventually the ultrastructure of your platelet. So with that being said, thank you so much for listening. So if you have any questions, I am opening the floor for your queries, clarifications before we end. So if you have a question, please acknowledge yourself on the chat box.